Okay, we continue our lecture. So now I would like to show you how we're going to use this equation, okay, in order to obtain the stiffness metric for each element. Go back to our initial example. We're using the same example, the one that we have defined 5 nodes with 4 elements. Now we would like to define the stiffness metric for each element. Okay, 1, 2, 3, and 4 by using this equation. Okay, so let's say this bar, okay, is made from steel with 200 gigapascal, the modulus Young, and the area, the cross-sectional area, is 1 meter square. While for the second bar is made from aluminium with the modulus elasticity or modulus Young 70 gigapascal, and the cross-sectional area is 0.5 meter square. Okay, for the first element, okay, the first element 1, we know that element 1, the length is 2 meter. Okay, the length is 2 meter, the E is 200, and the A, cross-sectional area, is 1 meter. So we replace into this equation, A 1 meter, E 200 times 10 power 9, and L equal to 2 meter. Then we will obtain this value, okay, 100. And note that for element 1 is between U1 and U2. So please note down on the above the matrix, U1 for column 1, U2 for column 2. And for first row is for U1, second row is for U2. Okay, please note down this notation as it make easier for us later on when we would like to assemble the matrix into global matrix. For element 2, okay, for element 2 is between node 2 and node 3. Note down is between here, so the length is 2 meter, okay, according to this one. We are still using the same bar, so meaning that the cross-sectional area is still 1 meter and the E is still 200 gigapascal. So replace into this equation, we will obtain the result exactly similar to K1 as the constant value is similar. And note that for element 2 is between U2 and U3. So please note down the notation U2 and U3 for the column as well as for the row U2 and U3. While for element 3, okay, element 3 by referring to this figure, it shows that element 3 is already in second bar, which is aluminium. So now for element 3, the E is 70, A equals to 0.5, and the L is 1 meter. So we replace into this equation, okay, A 0.5, E 70, and L equal to 1, and we obtain the value is 35. Okay, and note down that element 3 is between U3 and U4. So you have U3, U4, U3, U4. While for element 4, I'm sorry, here is number 4. Okay, element 4 is also coming from aluminium bar. Okay, aluminium bar from this one. So it's made from aluminium, 70 gigapascal. A still the same, 0.5. Okay, and the L for element 4 is 1 meter. So we replace back into this one. It should be 1 meter here, 1 meter, and we obtain the value 35, which is equal to K3. And note down that element 4 is between U4 and U5. So note down here U4, U5, U4, U5. Okay, so next, okay, once we have the stiffness metric for each element, now we can use it to form the global stiffness metric for the whole structure. Note that in our case, we have 5 nodes from U1 until U5, meaning that we have 5 nodes. Then we should have the size of the matrix for the global matrix 5 times 5, which is each nodes represent their own column and row. So we have 5 column and 5 row. Okay, so now we have to insert the matrix element by element. We start with the element first, element 1. Okay, element 1, referring to this element 1, we have U1 and U1, which is the value is 100. So we replace this value to this big matrix. Okay, so we have U1 and U1, which is 100. Then U2, U1, U2, U1, U2. So the value is negative 100. So to this big matrix, we insert this value, negative 100, at U1, U2. Okay, and then next, U2, U1. So we have negative 100. So U2, U1, negative 100. And lastly, we have U2, U2. So put according to its position, U2, U2. Okay, somewhere here. So we have 100. Now we move into second element. So second element, K2. Note that for second element, the matrix start from U2, U2. So U2, U2. Check U2, U2 somewhere here. So here you already have a value, so you need to add plus. Okay, so when you plus, you got another 100 at U2, U2. And then check U2, U3. Okay, this value U2, U3. So we have this value U2, U3. And then U3, U2. This value. So we have this value. And U3, U3. This value. So check U3, U3. So we have this value. Now let's move to element 3. Element 3 is start with U3, U3. Check U3, U3. Okay, U3, U3. So check from this table. We should have some at here. At U3, U3, around 35. Okay, so we have 35 here. At U3, U3. And then followed by U3, U4, U4, U3, and U4, U4. You should end with U4, 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 U4. If you replace the value, you should have this value. Okay, and for the last metric, okay, for the last metric we have K4. It start with U4, U4. Check U4, U4. Okay, U4, U4, 35. So you should have plus here. Plus 35. Okay, you should have plus 35. And then check U4, U5. It is 35, which is this one. Okay, U4, U5. And then U5, U4, which is this value. U5, U4, which is this value. And finally, U5, U5. This one, 35. Okay, you should have, sorry, here it should be positive, 35. Okay, so from here, the next step, we just need to solve the summation at the overlap. So we have here 200, here 100 plus 35, 135. Here 35 plus 35, 70, and the last one 35. And note that at the point we don't have any value, we just replace with 0. Okay, meaning that between node 1 and node 3, they have no connection. Okay, that's why the value is 0. So at the point at the position that have no value, we just replace with 0 value. Okay, and note that this first value is actually coming from K1, and then this one is coming from element 2, K2, and this one is from K3, and the last one is from K4. And we always have overlap at this point where we have to add, or we need to get a summation between the two elements, because the connection the U2 is repeating 2 times. Similarly for U3 at element 2 we have U3 and element 3 also we have U3 and U3, and similarly for U4 and U4. At this point there has overlap, so we just need to add between the two matrices. We will continue with other parts in the next video.